Hey guys, today we're going to practice balancing chemical formulas. So this is something that you should have done during physical science or your freshman year of science, and we're going to build off of it during this class and hopefully make it a little bit harder. So the first thing that I have you do is be able to count atoms in a chemical formula. This slide seems pretty easy. So the first example, we have calcium and we have chlorine. Calcium, there is only one element. Chlorine, there are two. So you have two chlorines bonded here. We have a total of 3 atoms or elements in this example. The next one is magnesium hydroxide, so MgOH2. Magnesium, there's only one. O and H we're going to list separately, and this 2 has to be distributed into the parentheses. So oxygen we actually have 2, and hydrogen we actually have 2. That's a total of 5 elements or atoms. Aluminum oxide, aluminum has 2, oxygen has 3, that is also a total of 5 atoms. And then this long one at the bottom, C6H7O2OH3, we're going to list out the elements in order. So C, H, O. And this O and this H can already be accounted for in this list, so we're not going to write it a second time. C has a total of 6 atoms. Right here, I have 7 H's, and according to this parentheses, I have an additional 3 on this side. So that's a total of 10 H's. Right here, I have 2 O's, and according to this parentheses, I have 3 inside the parentheses. That's a total of 5. And with this long molecule, we have a total of 21 atoms making up that element. So pretty simple, right? The whole premise of doing balancing chemical equations is being able to take chemical formulas and add coefficients out front. So this slide is going to show us how that's going to affect our numbers. So normally we would have had Mg, there's 1, and Cl, there's 1. But because this 2 is out front, we have to distribute this to both of the elements behind it. So Mg actually has 2, and Cl actually has 2. So for this second example, we have Mg, O, and H. According to this chemical formula, there's only one Mg present in the basic chemical formula. But since there's a 4 outside, we actually have 4 magnesiums in this substance or in this sample. Based on the parentheses here, we have to distribute this 2 into this O, so we have 2 O's here, and then we have to distribute the 4. We have a total of 8 O's. Again, distribute the 2 and distribute the 4, and we have a total of 8 H's. So our total here becomes 20 atoms in that sample, and our total up here becomes 4 atoms. So that's the first thing that I'm going to have you practice when you come back into class or when we start practicing in class tomorrow, is can you just count the elements or the atoms that are present in a chemical formula. But in addition to that, we are going to take it a step further. First, you have to be able to identify the different parts of a chemical equation. And there are 4 main parts. The first thing is the reactant. This is the stuff that goes into the equation. And that is actually everything on the left-hand side of the arrow. The second thing is the yield sign. This is just simply the arrow, and that's right here. So if you were to say this example, you would say C10H8 plus 12O2 yields 10 carbon dioxides and 4 water. After that, you would have the product, and this comes out of the equation. And this is everything after the arrow. And the last thing you have are the coefficients. And these are the numbers that are being placed out front that you are actually going to be using to balance these chemical reactions. So that's 12, 10, and 4. And even though there's nothing in front of this first chemical equation, technically there's a 1 there. These are the four main parts of the chemical equation. So if I ask you what are the reactants of this equation, you have to be able to at least identify, if not point them out. If I ask you what are the coefficients of this equation, you have to be able to identify the different coefficients based on the chemical formulas. So this whole idea of balancing chemical equations relates back to the law of conservation of mass. And in class, back towards the beginning of the school year, we did a lab that we took salt and dissolved it into a beaker of water. And the whole idea was that you had to determine what total mass the beaker, the water, and the salt would have after the dissolving took place. We determined that the total amount of salt plus the beaker and the water would be the same number before and after having it being dissolved. So if we started with 5 grams of salt and 150 grams of water and beaker, we would end with 155 grams all mixed up. This is the same idea. If we start with CO2, 1 carbon and 2 oxygens, we have to eventually have 1 carbon and 2 oxygens after the equation happens too. They can be bonded with other elements, but they still must be present. So steps for balancing a chemical reaction. There are 4 steps that I'm going to show you. The first step seems kind of silly. Determine if the equation is balanced or unbalanced. A lot of people assume that because I give you the problem, you have to complete it or balance it to make it correct. There will be times where the chemical equation is already balanced on the left and the right of the yield sign. You just have to confirm that it's done. So first we're going to look at this top example. N2H2 yields NH3. I can already see that I have 2 N's on this side and only 1 on the right. So I can determine this is an unbalanced chemical formula. Step 2, draw boxes around the chemical formulas, because you are not permitted to change anything within those boxes. So N2 is a valid chemical compound, 2 nitrogens bonded together. H2 is a valid chemical compound, 2 hydrogens bonded together. NH3 is a valid chemical compound also. These boxes essentially remind you that you can't just change anything in that chemical compound. If I put a 2 in here to try to change H's, that's going to end up changing what the substances actually are. So anything that is in the box is off limits. You may not change the chemical formulas. You can put anything you want to out front, but you cannot change or add anything inside the box. That's what those are reminding you of. Step 3, create an element inventory. So I'm going to show this to you in kind of a T-chart. So underneath this chemical formula, I'm going to put an N and an H down the center of a T-chart. On the left, I have 2 N's and I have 2 H's. On the right, I have 1 N and 3 H's. Now I'm going to add my boxes around those chemical compounds to remind me that I cannot change anything inside. And now that we have our element inventory created, we're going to move on to the next step. So a quick reminder, boxes to remind us we cannot change anything inside. T-chart with our elements listed directly below the arrow. 2 N's and 2 H's, 1 N and 3 H's. Now I'm going to try to balance my chemical formulas. So I'm not allowed to change anything inside, but I can add coefficients out front. So first I'm going to start with my H's. 2 and 3 both go into the value of 6. So I want to change both of my H's into having 6 H's. So I'm going to put 2 out front here, and when I do that, that changes this H to a 6, but it also changes this N to a 2. And then I'm going to put a 3 out front here, which changes that H also to a 6. So 2 and 2, 6 and 6, that chemical formula is balanced. We're going to do one more example together, and then we're going to make it a little bit harder. So we're going to make our element inventory. First, box the elements so I cannot change anything inside those boxes. Second, element inventory, I have tin, oxygen, and hydrogen. On the left, I have 1 tin, 2 oxygens, and 2 hydrogens. On the right, I have 1 tin, only 1 oxygen, and now 2 hydrogens. So at this point, everything is balanced except for the oxygens. So I'm going to try to make these two the same. If I have 2 on the left and I have 1 on the right, I don't want to make my numbers any smaller. I want to multiply to make them bigger. So I'm going to put a 2 out front of this O. That changes my 1 oxygen to 2, but it also changes my 2 hydrogens to being 4. So my tins are balanced, my oxygens are balanced. Now I'm going to balance my hydrogens. I have 2 and I have 4, so I want to put a 2 out front here to change that one to a 4. Okay? One last example. This one looks a little bit more confusing. So what I'm going to end up doing is just making the element inventory, and I'm going to kind of shorten it a little bit. So I'm just going to go straight down the middle and not make the T-chart part. And I have calcium, and I have hydrogen, but I also have this polyatomic ion. So notice I have NO3 on the left, and I have NO3 on the right. Since that is on both sides, I'm going to choose to keep it together and list NO3. You can separate those out if you want to, but it is going to be doing a little bit more work. So on the left, I have 1 calcium, I have 1 hydrogen, and I have 1 total NO3 molecule. On the right, I have 1 calcium, because there is no number down here. I have 2 hydrogens, and I have a total of 2 NO3 molecules. So if I keep these two together, I'm actually saving myself some balancing steps. Otherwise, I would have to distribute this 2 in, say I have 2 N's and I have 6 O's, and it ends up making it a little bit more work. When right now, all I have to do is look at the screen and say, if I have a 2 here and a 2 here, H and O3 is together, so all I have to do is put a 2 out front, and that changes both of these values, and that is already balanced. So this is the next thing that we're going to practice with. First, you're going to look at counting atoms and if you can determine the number of atoms in a chemical reaction in a chemical formula. Then you are going to look at adding coefficients to already created chemical formulas just to balance the masses before and after the equation. So I'll see you tomorrow so we can take a look at this and practice in class.